All right, everyone, welcome back. Okay, should be still the same day. It's Tuesday. Now we're going to take what we just did. I'll scroll up. What we just did, all this writing and equation, that was all nice doing it with nice points and numbers came out nice. Let's apply it to our real life stuff, our balloon bungees. I had meant to make this data here our class data we took on Monday or Tuesday, I believe it was. I didn't get a chance to change it, so we're just going to use this as an example. Whoa. We'll use this as an example. The first thing, we got to find a slope, just like we did before. We can't really use a slope formula because the numbers vary a little bit. I guess we could, but what I like to do is look at how each one of these changed each time we added a rubber band. This one's plus 10. 29 to 38, well, that's plus 9. 38 to 47, well, that's plus 9 again. 47 to 57, that's plus 10. And 57 to 65, that would be what, plus 8? A good way to, and we're going to do this a lot, but a good way to calculate reasonable stuff when you have data that's not nice is to take the average. Remember, the average is you add up all the numbers you have and then divide by how many of those you have. So let's do an average slope. It's not the slope formula. We're doing something else because we have real data, not just regular old points. So we have how many? 6. So we're going to divide by 6 since we have 6 data points. We have 6 rubber bands. Let's see. 10 plus 9 plus 9 plus 10 plus 8. These numbers are these numbers. Oh, if you hear that jingling, that's my dog coming in. Hey, Millie. Okay, let's add it up. I see a 10 and a 10, that's 20. 9 and 9 is 18, so 20 and 18 is 38, plus 8 more would be 46 over 6. That looks like it's going to be 7 point something. I'm getting out my calculator. Bum, bum, bum. You guys think I know all this math in my head? I use my calculator too. 46 divided by 6 gives me 7.66 repeating. So I'm going to say 7.67. All right, that's our slope. We'll say m equals that. Okay, finding the y-intercept. It's the same thing that we did up here. Let's see, where we had to pick a point and plug it in and then solve for b, the y-intercept. We're going to do the same thing. So let's pick a point. I'm just going to pick one that's right in the middle. Let's pick, well, yeah, let's pick one that's right in the middle. How about 338? If you want to pick a different one, that's fine. So our equation from y equals 7.67x plus b. We're going to plug in the 3 for the x and the 38 for the y, because they're the x and y coordinates. So 38 equals 7.67, our slope, times 3, the x value, plus b, the thing we're trying to find. Do that little multiplication. I'm getting my calculator. Times 7.67 times 3 gives me, dang, about 23 exactly. I'm going to round to 23. 38 equals 23 plus b. Subtract 23 on both sides. Subtract 23 on both sides. And I'm getting, I got to come over here. B equals 38, take away 23. That should be 15. 15. All right. So we have our slope. We have our y-intercept. We got an equation. Y equals 7.67x plus 15. Sweet. Okay, remember, if you need to pause and rewind and watch again or slow it down, that is fine. I'm going to ask that you pause it again. Here is, on the next part of your paper, another group. I want you to imagine another group did their balloon project, and this is their data. This is their data. Do the same thing we just did up top. Pause it though. I want you to pause the video, try this on your own. If you get stuck, you can come watch it, I guess. That's fine. But pause it and see how you do on your own. Okay? Pausing in 3, 2, 1. Okay, I hope you paused it. I'm going to go through this a little quicker. Okay? So the first thing is calculate the slope. Let's see what they did here. This one goes up by 8. This one goes up by, oh man, is that 15.5? That's not very consistent. This one goes up by, gosh, 7.5. I wonder what happened here. That's interesting. Am I doing my math right? 22 to 37.5? Yeah, close enough. If you find a mistake, good on you. This one, oh, I see what happened. This one went up 45 to 68. That's 23. And this one went up 20. Oh, wait, no. 16. Let me check my math. 8 plus 6, 14. Carry the 1, 7. I think that's about right. Look here. They didn't keep accurate data. They went 1, 2, 4, 5, 8, 10. So I wonder what a good slope might be. Well, from 2 to 4, and this is my own thinking, from 2 to 4, that's 2 rubber bands, and it went up about 15.5. Let's just split that in half since it's 2 rubber bands rather than going up by 1. So that'd be like 7.25, and this is 7.5, and this is 8. I'm going to just estimate, you guys. Estimating is good as long as you have reason behind it. I'm going to say the slope is about, that's what those double squiggles mean, about, let's say 7.5. Why not? 7.5. You guys took better data than this, so it'll work better for you. We'll say about 7.5. Let's find the y-intercept. I'm going to pick a nice point to plug in. Let's pick this one here, 545. If you picked a different one, that's fine. We might get something similar. We should get something kind of similar. Maybe different if you picked a different slope. So that means we're using y equals 7.5x plus b. And we're going to take the 5, plug it in for x, the 45, plug it in for y. So we've got 45 equals 7.5 times 5 plus b. That's just substituting in x and y. That's why you have x and y, is to plug them in. 7.5 times 5, I'm getting my calculator. 7.5 times 5, 37.5. Interesting. 45 equals 37.5 plus b. Subtract 37.5 on both sides. It's just an equation like we've done so many times. You guys know how to do this. B equals, hold on, let me get my calculator. I don't want to mess up. 37.5, 45, we're subtracting it. I'm seeing 7.5. Interesting. Okay, well, by my calculations, 7.5x plus 7.5. The slope and the y-intercept are the same. That's kind of interesting. Okay, that second example was a little, well, maybe a little trickier because we had to estimate a slope here. But this process is still the same, where you plug in the x and y, one of them, to see what you get. Okay? So if you need to go back and watch, I would say this is a better example to watch because your data should look like this, where you have going up by 1 rubber band at a time. So if you want to go watch that again, that'd be great. This is a good example too. What you need to do now is go sit with your group and copy your group's data here. The work that you just did yesterday, copy your group's data here, and then calculate a reasonable slope and the y-intercept and to create your equation. This is probably the most important part, is coming up with your equation, because when we go do our field test where we drop it from really high, you're going to use your equation. Okay? When I come back on Monday, we'll go through this and see how you guys did, and I want to hear what your equations are like. Okay?